All right, so we are now taking part of electrochemical processes or electrochemical cells. So we are in your notes book, and I believe this is page number 101 in your current notebook. So let me just kind of jot that down over here to the side. All right, so page 101. All right, so we can use the oxidation and reduction reactions to create an electrochemical process. And so that is a process that uses the redox reaction to perform a specific purpose. So remember, redox is oxidation and reduction. So the common things we're going to talk about in this unit are how a battery operates and how electroplating works. So if you have, like a gold Rolex watch, it's most likely going to be electroplated and not necessarily pure gold. So those are called the electrochemical processes. We have what's called an electrochemical cells, right? And they involve a chemical reaction and a flow of electrons, right? Because that's what we have. We have here electro. We've got our prefix of electron. So the flow of electrons is electricity, right? So electricity is our flow of electrons. And we have two different kinds of electrochemical cells. And so we have the Voltaic cell, which is our first. So I'm just going to write here, our first type of electrochemical cells is called Voltaic. And maybe you recognize the word volt, right? Because we have the word voltage, right? So a Voltaic cell is going to produce voltage. So an electrochemical cell in which a spontaneous, all right, so then that is an important part here, is the word spontaneous. It happens all by itself. A spontaneous chemical reaction produces a flow of electrons, right? That flow of electrons, right, comes from our redox reaction, right, where we have oxidation and reduction. Lose electrons, gain electrons, right? In that process of losing and gaining, we capture those electrons, and that's called a voltaic cell. And remember, a voltaic cell is spontaneous, and I like to remember that because it produces voltage by itself. So we need to understand the parts of our voltaic cell. So the first part is our anode, and that is the electrode in which oxidation takes place, right? So oxidation, again, is lose electrons, right? Electrons are produced here, right? So that's another way of saying lose electrons. And this is going to be the higher metal on table J. So the higher a metal is on table J, it is most likely to be oxidized, which means lose electrons. I'm just going to write that down here because the PowerPoint kind of went over what I wrote before. And oxidation is when we lose electrons. So the anode is negatively charged. So anode. So do you remember anion and cation, right? Cations are positive, but anions are negative ions, right? So our anode is negative, right? And so these are also the parts of a battery. So your negative terminal in a battery that you put into a flashlight or a controller or remote control, the negative side is the anode side. So now we also have a wire. We need some wires for the electricity to flow. And it allows the flow of electrons from the anode. So now this is important. Electrons flow from the anode to the other electrode, which we call the cathode, right? So alphabetical order, right? A to C, anode to cathode, right? So if we lose electrons on the anode, the cathode is going to be the opposite. We have a whole nother, part of the notes that's going to say about the cathode. So now the mobile electrons in the wire, right? Because wire is usually made out of metal. And I'm going to throw some review in here, right? Metals on our left side of the periodic table, right? They have those mobile electrons that allow electricity, right? It allows those electrons to flow through. So now let's look at, we have our anode, right? Anode was where oxidation occurs, losing electrons. And now we have the opposite. We have cathode, and this is the electrode where reduction occurs. Now the electrons are consumed here, right? This is consumed means in this case, gain electrons, right? Because gain electrons, reduction. And this is going to be our positively charged electrode, right? So then, which is where we get from cations, right? So oops, see, cations are positive. Right, so the positively charged terminal of your battery is called the cathode, which is where reduction occurs. So we have in every battery, there's an anode and a cathode, and they're connected by a wire. Right, and so our lower metal on table J is going to be reduced, right, which is lower reduced, right? So that's where the electrons are going to gain. So you're going to have two metals as your electrode. The higher metal is your anode, the lower metal is your cathode. So then these have to also be connected by something that's called a salt bridge. So that's a tube that contains a strong electrolyte. So remember, I like to say electrolytes give you acids, bases, and salts are electrolytes. And so remember, a salt is an ionic compound. Oops, ionic compounds. All right, so that's what a salt bridge is. And it allows ions, right? Because salts are ionic compounds. So it allows the ions to flow from one half to the other without mixing solutions. And it allows to what we call maintain neutrality. So I'm going to write that down here, maintain neutrality. It just prevents a buildup of charge, right? You don't want a buildup of charge on one side of your battery. So batteries have two sides, right? Positive side and negative side. And they are connected through wires, and there's a salt bridge. And then we have something that's called a voltmeter, and that just measures the voltage, right? So the voltmeter is just something that measures. That's all, the only function that the voltmeter has. Right, so those are all of the parts of our Voltaic cell. So now let's take a look at an example of a Voltaic cell. So this is what we could build in a lab. And here we have two beakers. And in this beaker, we have an aqueous solution of silver nitrate. And then we have zinc nitrate over here. So nitrates are very soluble according to our reference table F. So that's why you need to have an electrolyte, because we need to have the ability to move these ions. Here we have a salt bridge. So ions flow in and out here. So I'm just going to write here, this is our salt bridge. This is our voltmeter. Right, so this is just going to measure voltage. Right, anything you have meter is going to have to do with measurements. So now here we have an electrode, right? We have an aluminum electrode and we have a zinc electrode. So now aluminum is higher on table J. So then that's why I have assigned it the anode. Zinc is the lower metal on table J. So I'm just going to write lower J, right? So then these are my two electrodes. I have determined that since the aluminum is higher on table J, I assign that the anode. Our anode is negative. And now zinc is our lower metal. Our cathode is positive because cations are positive. And that little T in cathode looks like a plus, and N for negative, I guess that's the best way I can say. So what happens at the anode? Our anode is lose electrons. And at our cathode, this is where it gains electrons, right? Because anode is oxidation and reduction at the cathode, right? So reduction is gain, right? Leo the lion says grr, right? So reduction, and then lose electrons, oxidation, right? So that's so far what we've got here. So what happens here is this aluminum bar is going to lose electrons. Okay, so then the electrons are going to go through this wire, right? So let me just write down here that this is the wire. And electrons go through the wire from one side of the battery to another side of the battery. So the electrons get lost, right? So then it becomes an aluminum +3 ion that is aqueous. So what happens when those 3 electrons get lost, the electrons start losing, going up through the wire. That's where the electrons are going. And so then basically this is going to start breaking apart because ions are soluble in that aqueous solution. So my anode is going to end up getting smaller because the atoms form ions, right, by losing electrons. So now my electrons are always going to flow from the anode to the cathode. So my electron flow here is going to be, in this case, from left to right. So remember, this is just a 2-dimensional picture, right? If I have 2 beakers, I can just switch them around and you look at it, or I look at it from this direction, you look at it from this direction. So remember, this is just 2-dimensional. The zinc could be on the other side and then the aluminum on the, so the zinc could be over here on the left and the aluminum on the right. So don't always say, it's not always left to right. It's from the anode to the cathode, from the higher metal on table J to the lower metal on table J. And then these ions go in and out of the salt bridge, right? Because now if I keep pushing these positive ions, that means there's going to be more positive ions over here in this solution. So some negative ions will end up coming out. You don't need to know that. You just need to know ions go in and out here. So now let's look to see these electrons, right? These are negatively 1 charged electrons. And those electrons travel through the wire. And then now here I have electrons, right, going into this zinc cathode. And so now what gets reduced here, right? So if I add electrons to zinc, it's going to end up with a negative charge. But what's happening is it's this zinc, these zincs, right? Because I have zinc that's a positive 2 charge in the aqueous solution. And then plus I have these -1 nitrates in solution. So these are where the electrons get gained, right? Because those negative electrons are attracted to a positive charge. The zinc ions in this zinc nitrate is what those electrons are then attracted to. And then so every time that happens, we get zinc metal that's building up, right? Neutral zinc metal, right? Zinc 0 gets built up on this charge. So, right, if I have another, zinc ion from the zinc nitrate solution, gains some electrons, right? So I'll just write gain electrons here. And it starts to build up, right? And so now here we have zinc metal is going to start building up on top of this electrode. So then we lose and it gets smaller. And over here, gain electrons and the electrode gets larger, right? Or increases in mass, if you'd like to say it that way, because ions are going to gain electrons to form atoms. And over here, atoms form ions by losing electrons. So they're completely opposite. Very popular short answer question on the Regents exam or on redox tests is saying, in terms of ions, basically why an electrode will either increase or decrease in mass. So you have to say something about ions and atoms in terms of, ions and atoms, right? Because you have to say both words, right? If it says in terms of. So in terms of ions and atoms, right? The aluminum loses the aluminum atoms, right? Atoms form ions by losing electrons. And now over here, it's going to be the complete opposite. We're going to have ions gain electrons and form atoms. All right, and this is how the electrochemical cell that's called the Voltaic cell, this is how it operates. Now we can choose different metals. Different metals are going to give you the different voltages. So in honors chemistry, we calculate that voltage, and in college chemistry, we calculate that voltage. What metal you choose is going to determine the output of a Voltaic cell. All right, and then we have some wire. So let me just kind of just go through here. Let me just quickly go through because I just wrote those all out. Okay, so these are some memory tricks. We have a fat red cat. Let me just see if I can move my little bar down here for a little bit. Okay, fat red cat ate an anorexic ox. Right, so this is how we're going to help to memorize and help to understand our Voltaic cell, our Voltaic electrochemical cell. So there are two electrochemical cells, Voltaic and electrolytic. So this is going to be our Voltaic. So reduction occurs at the cathode, so red cat. So then this is why I have a red cat. It's a pretty ugly red cat, right? So reduction occurs at the cathode. What is reduction? Gain electrons reduction, right? So the red cat says GR. So then the cathode gains electrons, it increases in size. This is why we say a fat red cat. My cat's really not that fat. It's got a really big fat head, right? Fat red cat. And our oxidation occurs at the anode, right? So an ox. Let me show you. Hold on. Let me grab an the ox. This is why I have stuffed animals on my desk. This is Anne the ox, right? So Anne the ox, right? She's on a diet. She's getting smaller, okay? So oxidation occurs at the anode, right? So Anne ox, right? So how about A-N-N-E, Anne ox? And the anode loses electrons and gets smaller. So that's right, smaller. And then remember, Leo the lion says GR, right? Lose electrons, right? So lose electrons, gains electrons, right? So let's just, so Leo the lion. All right, so then in our next video, we'll talk about the second type of cell, which is our electrolytic cell. All right, so hopefully you enjoyed our Voltaic cells.